All right, let's talk about a core piece of any healthy Kubernetes cluster, the DaemonSet. It's the one controller that guarantees a specific pod is running on every single node you need it to. Let's get right into it. You know, we're always told that Kubernetes treats servers like cattle, not pets. And that's the whole point, right? To abstract away the individual machine so you don't have to care where your app lands. But what happens when you absolutely have to care? What if you need a shepherd, like a logging agent or a network plugin, on every single field just to keep the whole herd healthy? And that right there, that's the core conflict, the node local problem. This is where the beautiful, clean abstraction of Kubernetes bumps up against the messy reality of running real infrastructure. You just can't run things like log collection or node monitoring in some kind of abstract void. No, they have to run on the specific node they're meant to be servicing. This really captures the fundamental mindset shift. You see, a deployment, which we all know, is all about quantity. It asks, how many copies of this app do I need? But a DaemonSet flips the script entirely. It's all about placement. It asks, which specific nodes out there require this capability? So we're moving from how many to where. So let's get a really clear definition down. A DaemonSet is a Kubernetes controller, and its entire job, its whole reason for being, is to make sure that a copy of a particular pod is running on a specific set of nodes. And yeah, most of the time, that means all of them. It's a guarantee of presence. It's a promise that your shepherd is always on duty. And this table just lays it out perfectly. A DaemonSet has a totally different goal than a deployment. It's for these node local agents, not for scaling your apps. And its scheduling logic, it's not just about finding any old open slot, it's deterministic. One pod for each eligible node, period. And scaling, you don't set a replica count, it just scales with your cluster. You add a node, boom, you get a new pod. You remove a node, that pod is gone. Simple as that. Okay, but every node doesn't always mean every single node, right? Maybe you've got some GPU nodes that need special drivers, or control plane nodes you want to watch differently. For that, you need precision. So let's talk about targeting the right nodes. Now, Kubernetes gives us a pretty powerful toolkit for this. You've got your simple nodeSelector and your more complex node affinity rules. But honestly, the most critical mechanism, especially when you're talking about cluster health, is this kind of push and pull dance between taints and tolerations. Let's see how that works. So first up, you have taints. Just think of a taint as a repel shield you put on a node. The node is basically shouting, hey, don't schedule any pods on me unless you have the secret password. And what's that secret password? Well, that's the toleration. It's a little piece of code you add to your pod spec that says, it's cool, I've got permission to ignore that node's repel shield. The pod literally has the key to get past the node's lock. So, why is this whole system so vital for DaemonSets? Because, as it says here, DaemonSets are basically your cluster's immune system. They're your monitoring agents and your network plugins. They absolutely have to keep working, especially when a node is unhealthy or cordoned off for maintenance. I mean, that's exactly when you need them the most. And the really cool part is, Kubernetes totally gets this. The DaemonSet controller automatically adds a whole set of these critical tolerations to every single DaemonSet pod. It tolerates nodes that are not ready, unreachable, under disk pressure, or even marked as unschedulable. This built-in immune response is what keeps your cluster observable and running, even when things are starting to go wrong. Okay, so we get the mechanics, but what are these critical pods actually doing? Let's dive into the concrete use cases and look at the cluster's critical systems. Make no mistake, DaemonSets run the absolute backbone of your cluster. They're the container network interface, your cluster's nervous system, giving all your apps IP addresses. They're the log collectors, its sensory system, grabbing the logs you need to figure out what went wrong. They're the node monitoring agents, its health check, telling you if a server is about to fall over. And they're the storage drivers, its hands, physically attaching disks to your nodes. This is so important to understand. These systems are all connected. Just look at this failure cascade for the CNI plugin. If that one DaemonSet fails to start on a new node, the node never becomes network ready. That flips its status to not ready, and guess what? Any other application pod scheduled there is dead in the water. One DaemonSet failure can literally take an entire node offline. So that brings up a really critical question, right? If these things are so essential, how on earth do you update them without causing a massive cluster-wide outage? Well, that's what we're going to cover next: updates and survival tactics. So you've basically got two main flavors. On delete is your super safe manual option. Nothing happens until you physically delete an old pod yourself. This gives you total control. Then you have the default rolling update, which handles the whole process automatically, killing old pods and creating new ones in a controlled way. It's that classic trade-off between manual safety and automated speed. Now, with a rolling update, there's a really key difference from deployments. You can't surge a DaemonSet. I mean, you can't have two logging agents running on the same node, right? So your only real control knob is max unavailable. This setting just defines the maximum number of nodes that can be in the middle of an update at the same time. A pretty common value you'll see for the setting is 10%. So let's see what that actually looks like. On a huge 1,000-node cluster, setting max unavailable to 10% means 100 of your critical node agents are being updated all at once. Yeah, this makes your rollout super fast, but it also massively increases the blast radius if there's a bug in the new version. Why this matters is obvious. Picking this number is a direct trade-off you have to make between speed and risk. Okay, finally, how do we keep these vital agents alive? That brings us to our last topic: resource management. We have to make sure our guardians don't get starved of CPU or memory by the very applications they're trying to support. The single most important tool you have for this is the priority class. By setting the priority class name to system node critical for something like your CNI plugin, you're basically screaming at Kubernetes that this pod is non-negotiable. If a node runs out of memory, the scheduler will start killing your application pods to make sure this critical agent survives. It's an absolutely essential protection mechanism. So let's wrap this up. The key takeaway is this: your applications are only ever as stable and reliable as the infrastructure that's running underneath them. And inside your cluster, DaemonSets are that infrastructure. So I'll just leave you with this final thought. Take a hard look at your own clusters. Are your DaemonSets really configured with the priority and the resources they truly deserve? Thanks for watching.